Good morning, everybody. This is Dr. S. Jyoti Lakshmi, Assistant Professor, RMK College of Engineering and Technology. Today, our topic for discussion is fuel cells. Now, what are these fuel cells? Fuel cells are cells that convert the fuels directly into electric current without combustion. Without burning, the fuels are directly converted into electric current. Here, the fuels can be hydrogen or methane, etc., which can be converted into electric current. So, the fuels used here are generally gas or liquid, and here oxygen will be acting as the oxidant. So there are different fuel cells that convert chemical energy into electrical energy, which has 100% of efficiency. So the cell is represented as follows: fuel, then comes the electrode, electrolyte, electrode, and oxidant. The types of fuels are hydrogen oxygen fuel cell, methanol oxygen fuel cell. What are the limitations of fuel cell? See, this fuel cells has large weight and volume of hydrogen gas fuel storage system. It has high cost of hydrogen gas, as well as technological advances should bring the cost down, because it is costlier to get the hydrogen gas, and maintain it at 1 atmospheric pressure. Reducing the pressure is becoming a greater task. In the same way, there are lack of infrastructure for distribution, for carrying and marketing of hydrogen gas, and more basic fuel cells suffer from carbon dioxide leakages, and it should be prevented from entering the cell and reacting with the electrolyte. So no other gases should interact with the fuels that we are using. So we should be careful enough. So now we are going to discuss about hydrogen oxygen fuel cell. So in this fuel cell, we use hydrogen as the anode and oxygen as the cathode. As we use gases, we cannot maintain it as anode and cathode. We will be taking graphite or carbon, which acts as the electrode, through which we will pass anode for oxidation reaction as a hydrogen, and for reduction we will be using the cathode as our oxygen. And here the electrolyte that we are going to use is aqueous KOH. It is in the percentage of 25 to 30%. And we know that the hydrogen and the oxygen which we are using should be of high purity, and oxygen here acts as the oxidant. In the same way, when we see into the reaction, there will be no other chemical or no other product that is formed. It forms only water, and on the other hand, it also produces the current. At anode, see, we have already used hydrogen. So that hydrogen acts as the anode and combines with the negative part of the electrolyte. So our electrolyte here is KOH, that is aqueous KOH. The negative part of KOH is OH minus. So it reacts with, we know that we are using aqueous KOH. So we know that your KOH is prepared with water. So it is aqueous KOH. So the anode hydrogen reacts with the negative part of the electrolyte, forming water by liberating electrons. At anode, oxygen combines with water. So this water is from this aqueous KOH. So we are producing the KOH in the aqueous medium. So we are using water. It takes up the 4 electron and it gets reduced to OH minus. So we have already discussed that at anode oxidation takes place and at cathode reduction takes place. So the overall reaction will be, see, this water gets cancelled. We'll be having only 2 moles of water here. 4 OH gets cancelled. 4 electron gets cancelled. So remaining will be 2H2 plus O2 giving 2H2. That will be the overall reaction. And the product discharged, we know that it is only the water. No other chemical is being formed. And the standard EMF is 1.23 volt. So mainly we use this fuel cell in the spaceships, in the vehicles and in the submarines and military vehicles, where it is easy for them to carry hydrogen and oxygen in the form of gases. And there we get only the water, which is a valuable fresh water, and it will be the source for astronauts also, because they can do two works. That is, they can produce electricity. On the other hand, they can also use water as the byproduct. In the same way, we are going to discuss about our next fuel cell, methanol oxygen fuel cell. So here my methanol is acting as the fuel, and in the same way oxygen is acting as the oxidant to generate electric current. So this will be the reaction at the anode. At the anode, CH3OH, methanol, will be acting as the anode, and at the cathode, oxygen gets reduced to hydroxide. So as I have told you earlier, methanol, that is anode, reacts with the negative part of the electrolyte. Here the negative part of the electrolyte is OH minus. It produces carbon dioxide, water, and it gives away the electron. That electron will be taken up by the cathode. It gets reduced to hydroxide. So the net reaction will be here. Also, water molecule gets cancelled. So remaining we have two water molecule here. Six electron gets cancelled. 6 OH gets cancelled. So remaining will be methanol plus 3 by 2 oxygen gives carbon dioxide plus 2 water molecules. So advantages, these cells are reasonably stable at all environmental conditions. So it is not like our hydrogen oxygen, where the hydrogen maintaining at 1 atmospheric pressure, carrying storage becomes a problem. Here it is also easy to transport. It does not require any complex steam reforming operations, and methanol poses less risk to aquatic life, animals and human beings than gasoline that we use. Advantages of fuel cell: the reactants and the products are eco-friendly. It does not harm the environment. A high efficiency of energy conversion from chemical energy into electrical energy, and the fuel and the electrolyte materials are available in plenty and inhospitable, unlike our fossil fuel. So we can rely on this, and we can go on for usage in our vehicles also. So fuel cells are operable to 200 degrees centigrade, and it finds applications in higher temperature systems also. And the fuel energy is economical and safe. In the same way, fuel cells are also compact and transportable. So we will stop with this for today's class. We will discuss the remaining in the next class. Thank you.